Okay, I'm going to talk about interest. All right? We'll start with simple interest before we move on to more complicated types of interest. So simple interest, I equals principal times rate times time. This should look familiar from your school days, where principal is the amount of the starting balance on the account, rate is R as a decimal, converted to decimal form, and T is the time. So, $2,320 is borrowed at 18.75% for 6.5 years. A, find the interest. B, find the accumulated value of the account to the lender. Okay? Because why is the accumulated value of the lender? Because they're going to get $2,320 worth of payments out of you plus the interest. Okay? So A. Okay? P is 2320. R is 0.1875. If you don't remember how to do this from school, just take the percent form and divide by 100. Okay? And T is 6.5. 6.5 years is 6.5. So I equals 2320 times 0.1875 times 6.5. Okay, so 2320 times 0.1875 times 6.5. $2,827.50. B, accumulated value is the $2,320 that will be repaid plus the $2,827.50. Equals $5,147.50 or $5,147.50. Okay? I'm going to pause here and put up other types of interest formulas. Okay, here I'm going to discuss other type of interest, okay? Compound interest. Compound interest has two subtypes, continuous and periodic. Now, some courses include periodic only, okay? College algebra classes, business math class, advanced business math classes, applied calculus classes, which is also business, usually business calculus, usually include both of them as well. I think it's easier to start with continuous, so that's what I'm going to do first. Okay? So, but I will at least give people an idea of what this looks like for later. Okay? So, accumulated value equals the principal, and then this is where things change, become different between the two of them. E is a constant. It's 2.71. It's approximately 2.718281828,459, and then it goes all over the place forever. Okay? You'll hit shift or second. You'll hit shift or second LN on your calculator to get to that feature. Okay? For periodic, it's 1 plus the rate as a decimal, and this is still time. This is what causes the most confusion because it's usually never given as a number. Okay? It's a number of compoundings per year. Now, if it says it's compounded monthly, there's 12 months in a year, so n would be 12. If it's compounded annually, there's only 1 year per year, so n would be 1. If it's compounded quarterly, there's 4 quarters in a year, so n would be 4. And semi-annually, that's every half year, so that's twice a year. Okay? So, Purple Grove offers 4.45% interest compounded continuously. If 1,040 is deposited now, find balance in 9 years. So do. It says it's compounded continuously, so the appropriate formula is the continuous compounding formula. Okay? Now, before I start plugging things in, I try to identify what the variables are, what the variable values are, because sometimes it's not as simple as it seems. So 1,040 is what we're starting with. That's our principal. We're looking for what the balance is going to be, an accumulated value in 9 years. Rate, either move the decimal point over 2 places or just divide that by 100, is 0.0445, and t is 9 years. So A equals 1,040 times e to the 0.400, e to the 0.0445 times 9th power. Okay? I always every calculator handles this differently. So what I would recommend you do is multiply this out. Okay? So leave the e, 0.0445 times 9 is 0.4005. Okay. Now, on my calculator, which is a Casio, you will see, and you will typically see an LN button. On my calculator, it's right there. Some calculators, it may look like a capital I, but it's actually LN. Okay? Right above that LN, you will see e to a power. Okay? Now, I can't get this thing to focus. Okay? But above, you should be able to find e to a power if you hit shift or second. So, for me, I would just type in 1,040 times shift or second, depending on what your calculator says, ln. So again, 1,040 times shift or second ln. Okay? This is what it looks like on the calculator that I'm using. Okay? And in the nearest set, that's 2 decimal places, 1552, sorry, 0.27. Okay? Now for this one, it's still continuous. A equals PE to the RTth power, where A equals, P equals, R equals, T equals. Well, rate is still what it was before. T is 9. Now that 1,600 is what we're hoping to have in 9 years. That is an accumulated value. We don't know what we're depositing, what we're starting with. As I said, determine what your values are before you start plugging things in. So I want to know when 1,600 will equal e to the P times e to the 0.0445 times 9th power. Okay, that's my unknown. That is what I'm solving for. So what I'm going to do is, since that's my unknown, I'm going to switch the side and move it over here. Okay, so I have P. I am going to go ahead and simplify the exponent. I'm going to pretend that I don't know what the answer to this is. So 0.4005 times 9, sorry, 0.0445 times 9 gives me 0.4005 equals 1,600. Now, my goal is to undo, I got P times this e to something. I'm going to do the multiplication by dividing. And yes, that is the arithmetic division symbol, and that's what I'm going to use. So P equals 1,600 divided by e to the 0.4005th power. Okay, so I'll do similar to what I did here, except instead of timesing, I'm going to divide. So 1,600 division, shift or second, ln, 0.4005. This is what it looks like on my calculator. Okay, if I can get it to show. Again, I'm sorry the lighting isn't very good in here. Okay, not for this. I have to darken it because I want the board to be very visibly clear. Okay. Maybe this other calculator will be a little clearer. Yeah, that looks better. Okay, hit enter or equal. Okay, so the nearest cent, that's going to be $1,071.98. The problem also said it wants the nearest dollar. So the nearest dollar, that is $1,072. Unless given reason to do otherwise, unless given reason to do otherwise, assume nearest cent. Unless given reason to assume otherwise. Okay, this next part says, how long would it take for 1,040 to grow to $1,700? Well, it's still compounded continuously, so this is still the appropriate formula. Okay, so A equals, P equals, R equals, T equals. So the accumulated value is going to be 1,700, and we're starting with 1,040. The rate is 0.0445, and T is unknown. Okay, that's the question. So I want to know, when will 1,700 equal 1,040 times e to the 0.0445 teeth power. Okay, t is my unknown, so I'm going to go ahead and switch the sides so it's on my left. Okay, and then I'm going to go ahead and divide out that 1,040 and reduce. So e to the 0.0445 teeth power is 170. Actually, it can be reduced even more. Actually, I'll just truncate those zeros. And then these two are also divisible by 2. So 85. So 1,700, 1,040ths. That is 85/50 seconds. You don't actually have to reduce if you don't want to, because it'll come out the same in terms of, decimal form. All right? So that's base E, so I'm going to use a natural log. Like so. Okay? Since ln equals log base E, that allows me to take, that cancels raising e to a power and leaves me 0.0045t equals the natural log of 85/50 seconds. Okay, I'm going to diagonalize the fraction because I might be running low on space. Okay, so the next thing I'm going to do is divide off that 0.0445. Okay? I'll use a division symbol, the arithmetic division symbol. Okay, so T is approximately, so on my calculator, I'm going to type in the ln, 85, division or fraction bar, 52, balance the parentheses. Make sure that the parentheses are balanced. I go ahead and hit enter or equal, 0.4914 something, and then divide by 0.0445. T is approximately 11.0 0.043 years. Okay? Okay. D, find doubling time. Okay, well, we'll find the doubling time. So here it goes. Maybe we could, you could literally make any number up and just double it, okay? But we've been using 1,040 for a deposit, so we'll use 1,040 for a deposit, okay? Suppose P is 1,040. How long for 1,040 to double to 2080? Okay, if you want to do 100, you'd be how long for it to double to 200? If you want to do 1,000, how long for 1,000 to become 2,000? It really doesn't matter what you start with as long as you double it. So this would be my P, this would be my A. Okay, so A equals PE to the RTth power because it's continuous. Okay, so how long? So A equals, P equals, R equals, T equals. So A is 2080. P is 1,040. R is 0.0445. And T is, I don't know. That's the question. Okay, so I want to know how long for 2080 to become equal to 1,040 e to the 0.0445 teeth power. So I propose to switch the sides and divide. So divide this off, and we have e to the 0.0445 teeth power equals 2. Okay? It's base e, so we'll use a natural log, which is log base e. All right? So that takes that out of the exponent. We have 0.0445 t equals a natural log of 2. Okay? All I need to do now is divide off that 0.004, or that 0.0445. Might want to put that in parentheses to be on the safe side. And t is approximately, so natural log of 2, hit enter or equal, I'm looking at 0.6931471 blah, blah, blah. Okay, and divide off the 0.0445. Okay, I'm looking at approximately 15.58 years. Okay? Analogously, part E, find the tripling time. Okay? So let's suppose P is 1,080. Okay? Or 1,040, which is what we've been using. Okay? For our deposit. You can, for the purposes of finding tripling times, doubling times, you can make up any number and double it. That's pretty much all you have to do. So suppose P is 1,040. How long for 1,040 to triple to 3120? PA. Okay? So, if A equals PE to the RTth power, I want to know, so A equals, P equals, R equals T equals. So A is 1,040. P is, or I'm sorry, P is, we're starting with 1,040. We're tripling it to 3120. Okay. The rate is still 0.0445, and T is we don't know. So when will 3120 equal 1,040 e to the 0.0445 times 9th power, times tth power. Okay, I'm sorry, my brain went back in time. Okay, I'm solving for t, so I will switch the sides and divide. So 1,040, because t is my unknown, so I want to move that side to my left. E to the 0.0445 tth power equals 3120. Divide off the 1,040. And I'm left with e to the 0.0445 tth power equals 3. Okay? Doubling time, you end up with 2. Tripling time, you end up with 3. If you ask for quadrupling time, you end up with 4. Okay? So, that's e to an unknown power. We'll do natural log, which is log base e. Okay? That takes this, that undoes the exponentiation and just leaves me the 0.0445t. Okay, and then I'm going to divide off that 0.0045. Sorry, that 0.0445. Okay, I'm going to put it in parentheses and just use a division symbol. Okay, so natural log of 3, hit enter or equal. I'm looking at 1.0986 blah blah blah, divide by the 0.0445. I'm looking at approximately 24.7 years. Okay, Purple Grove Credit Union offers 4.55% interest compounded monthly. Okay, if 1,040 is deposited now, find balance in 9 years. So it is a non-continuous. That means it's monthly, it's periodic. So this is the appropriate formula. Okay? So, A equals, P equals, R equals, N equals, and T equals. So N is 12. It's compounded monthly. Okay? The rate is 0.0455. Time is, in this context, 1,040 is deposited now, find balance in 9 years, and we're starting with 1,040. We don't know what the accumulated value will be in 9 years. That's the question. So A equals 1,040 times 1 plus 0.0455 over 12 to 12 times 9th power. Okay? I strongly recommend you clean this up. And never round. Never round. Okay? Never round that. Never round. I'll erase that, but I want to make sure it gets read. Never round. If it doesn't terminate, if it's a repeating decimal, then you keep it as is in parentheses. Okay? That's 108. I'll pretend that that's simply 108. So A equals 1,040. That, and I'm going to see if that divides cleanly. I don't think it does. So 0.0455 divided by 12 plus 1. So what I went ahead and did is I went ahead and took the 0.04, divide first, then add. Okay? And as you can see, there's a bar on top of my 6 that tells me it repeats forever. Okay? So that doesn't divide cleanly. So I'm going to leave it as is. Most problems will not round cleanly, so I recommend you get in the habit of just leaving these in parentheses. Okay, now most calculators, this isn't going to be a problem. You just type in the 1040 times, open a parenthesis. I'm going to say that again. 1040 times, open a parenthesis, 1 plus 0.0455 divided by 12. Balance the parenthesis, and then generic exponent button 108. So the nearest cent, I got $1,565.09. Okay, unless given reason to assume otherwise, you will round to 2 decimal places to the nearest cent. Okay, so for this one, same formula. Okay, so A equals, P equals, R equals, N equals, and T equals. So the cumulative value is going to be 16. So it's compound monthly, so N will be 12 throughout this problem. The rate is 0.0445 or 0.0455. Sorry, my brain was still on the last example, on another example. T is 9. And this 1600 goes with the future value. We don't know what we're starting with. That's the question. Okay? So I want to know 1600 equals P times 1 plus 0.0455 divided by 12 to 12 times 9th power. Clean that up, and since P is my unknown, I'm going to switch the sides. Okay, and I hope everything is still visible on screen. It is, good. Okay, so P times 1 plus over 12, that's 108, equals 1600. Okay, so my dream is to divide this off, because I got P times a whole bunch of stuff. So I'm going to divide off that whole bunch of stuff. Okay, so P, that looks more like a D, I'm sorry. P equals the 1600 divided by 1 plus 0.0455 divided by 12 to the 108th power. Okay? If you're using a Casio and most Texas Instruments calculators, this is not a problem. If you're using one of those calculators that doesn't support the order of operations, this is a little dicey. Okay? But for those of you who are using a good calculator, this is not a problem. Just type in the 1600 division, parenthesis. Very important that you include that parenthesis. 1 plus 0.0455 division 12. Balance the parenthesis, your generic exponent button 108. To the nearest cent, I got $1,063.19 rounded to 2 decimal places. Okay. Okay, so now we're going to talk about a more advanced problem. So how long, or more advanced problems, how long would it take under these conditions for 1,040 to grow to 1,700? Well, it's periodic, compounded monthly. Okay, so A equals, P equals, R equals, N equals, and T equals. So, I want to know how long it will take for, if we start with 1,040, for it to grow into an accumulated value of 1,700. Okay, the rate is 0.0455 as a decimal. It's compounded monthly. What we don't know is the time. That's the mystery. How long would it take? So I want to know how long it will take for 1,700 to equal 1,040 times 1 plus 0.0455 over 12 to 12th power. Okay? T is my unknown, so I'll go ahead and switch the sides. So 1,040, 1 plus 0.0455 over 12 to 12th power equals 1,700. Okay? I like to have my unknowns on the left. Okay, a lot of math people do. Okay, divide off that 1,040, and we have 1 plus 0.0455 over 12 to 12th power equals 85/50 seconds. Any fraction capable calculator can tell you that. But where I originally got it from was I divided by 10 to cancel the zeros, and then both those two were divisible by 2. Okay, that's how I did it earlier. Okay, off camera. All right, so we have the logarithm. So what I want to do, sorry, I'm using another method, so I'm going to erase it. Forget I did that. Okay, so I want to get t out of the exponent. All right, so I'm going to use a natural log. Divide off the 12 to 12th power equals a natural log of 85/50 seconds. Now, this natural log is log base e. Log base e of something else, of another base, allows me to take this 12t to the front. All right. Now, the next thing I'm going to do is I've got t being multiplied by 12 and by this natural log. So what I propose to do is simply divide them off. Divide off. Okay, so I have t equals the natural log of 85/50 seconds divided by 12 divided by natural log of 1 plus 0.0455 over 12. I will do each of these one at a time. So, natural log, parenthesis, natural log, parenthesis, 85, fraction button or division button, 52nd. Balance the parenthesis, hit enter or equal. I am looking at 0.4914 something. Another option you may be looking at is that's something else you may be seeing. Natural log 85/50 seconds. Either way, you should have 0.4914 something. Now, divide by 12, hit enter or equal. Now I'm looking at 0.0409 5 something. Now divide natural log, parenthesis, very important that you include that parenthesis, 1 plus 0.0455 divided by 12, balance the parenthesis, and we get approximately 10.82 years. All right. Okay, find doubling time. For this, you're just looking for the amount of time it would take for any amount to double. So you could start with 1,000, see how long it takes to get to 2,000. You could start with 100 and see how long it takes to get to 200. You could start with 300 and see how long it takes to get to 600. Okay? We've been using 1,040 for the deposit, so let's just go ahead and keep doing that. Okay? Do. How long, or how about this? Suppose P is 1,040. It's what we've been using for a deposit for several examples, so, or parts of this, so we'll go ahead and use it again. How long for 1,040 to double to 2080? Okay, that's what we want to know. Okay, so this will be our principal, this will be our accumulated value. Okay, so how long for, if the formula is A equals P times 1 plus R over N to the n-th power, where A equals, P equals, R equals, N equals, and T equals. We don't know the time, that's the question. It's compound monthly, so 12 times a year, 0.0455. A is 2080, and P is 1,040. So how long for 2080 to equal 1,040 times 1 plus 0.0455 over 12 to 12th power? Okay. Well, this is my unknown, so I'm going to switch the sides so my unknown is on the left. So 1,040 times 1 plus 0.0455 over 12 to 12th power how long will it take for it to equal 2,080? I'm going to go ahead and divide off this 1,040. And unsurprisingly, we end up with 2. So 1 plus 0.0455 over 12 to 12th power equals 2. Okay, I want to get the t out of the exponent, so I'll use a natural log. Now, that is a base, that's log base e of a base other than e, so I can take that exponent to the front. So I have 12t natural log of 1 plus 0.0455 over 12 equals a natural log of 2. Okay, so here's what I have going on. T is being multiplied by 12 and this natural log. So I will divide both of those off. Divide off. So the t equals natural log of 2, to be on the safe side, I will put it in parentheses, divided by 12 divided by the natural log of stuff, of a bunch of stuff. Okay, so I'll whip out my calculator. I'll take the natural log of 2 and hit enter or equal. I am looking at 0.693 blah blah blah. Now, with that number still in my calculator, divide by 12 and hit enter or equal. Now I'm looking at 0.5776 blah blah blah. Divide. Natural log, parenthesis. Be very careful to include the parentheses. 1 plus 0.0455 division 12. Balance the parenthesis, approximately 15.26 years. And that will suffice.